We just wrote a quiz and did pretty well on that quiz where we had to add vectors together that look something like this. I don't remember exactly what your quiz looked like, but in the end, we had vectors that we were adding together that were at 90 degrees to one another. We can do that, right? We can do that because in the end, all we have to do in those cases is get our x component and our y component of each vector, add them all up, get a total x, get a total y, and then recombine them in a right angle triangle, which is exactly what we want. Then we can do the Pythagorean theorem, we can do the inverse tan function. But what if this last vector doesn't look like this? Okay, what if that last vector isn't straight up? What if that last vector looks more like this, where it's at an angle of, let's say, 40 degrees, instead of at an angle of 90 degrees. We still have to do the same thing. We still have to get the x's and the y's, recombine them into a right angle triangle, and use the Pythagorean theorem in the inverse tan function. But getting the x and y components of this last one is not nearly as easy as getting the x and y components of the rest of them, like it was in the question that we had on our quiz. So how exactly do we get the x and the y components of this vector? Well, remember that we've got to, as soon as we see a vector like that, in any context, at an angle of 30 degrees or 40 degrees or 67 degrees or whatever the case may be, we've got to think 5 words. 5 words should come to our mind whenever we see that vector or any other vector that's at an angle like this. What are those 5 words? I don't like funny angles. Good. I don't like funny angles. Okay, I want you to think that all through Physics 20 and all through Physics 30, because we're going to see those funny angles a lot in this context and in lots of other different contexts as well. Every time you see it in any context, I want you to think, I don't like funny angles. And when you don't like funny angles, you got to get rid of it. Essentially, what you're going to try to do is turn that vector, okay, that's at 40 degrees into an x component and a y component, and then it makes the problem just like the question that we had on our quiz. Right? So we have to turn this into this and this so that it looks more like the typical question that we've done over the last couple of days. All right, so how do we do that? How do we do that? Well, let's say I have a vector at, we'll make it 30 degrees because the math is easier at 30 degrees here. That would be 30 degrees what of what, by the way? It's measured from which axis? Is it measured from north, east, south, or west? Guesser? It's measured from the west, right? Now it's measured from this guy as well, but that's not north, south, east, or west. It's measured from this dotted line, which is west. So we're going to say something from west or something of west. What would it be, Emily? Yeah, it's going north from the west, so we'd say it would be north of west, 30 degrees north of west. Let's say our value of our vector here is 10 meters. We want to find the x and y components. What would we replace it with? Well, let's draw a triangle around it. The triangle around it should contain the angle. The angle should be inside that triangle. We could draw like this. That's a triangle. Okay, but we don't want to do that because the angle isn't inside the triangle there. Make sure you put arrows on this as well. Don't skip out on this. Okay, this is important to draw these arrows. We know to draw the horizontal arrow to the left because the 10 meters is going to the left and up. And of course, the other one's going to go up because left and up. We're going to label this x. We're going to label this y. And we're going to find the value of the x component and the y component. How much of it's x, how much of it's y. We're going to say the x component is going to be found by using the cosine function. And the reason we use the cosine function here is because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And we've got the adjacent side that we're looking for, and we have the value of the hypotenuse here. Cosine 30 degrees is equal to adjacent over hypotenuse, or x over 10 meters. X ends up being equal to 8.66 if you do that on your calculator. Sine 30 degrees is equal to y over 10. So y is equal to 10 sine 30. Why sine? Well, because sine is opposite of hypotenuse, and the y component is the opposite side of the triangle. 10 sine 30 is 5.0 meters. So what I can do now what I can do now is take that 10 meters at 30 degrees that I don't like. Okay, we've already established that we don't like funny angles. We can take that 10 meters at 30 degrees and pretend it's not even there. Relabel the x component as 8.66 and the y component as 5.0 meters. Make sense? This is easier to deal with. We've dealt with vectors like this lots over the last couple of days. Now we can turn that 10 meters at 30 degrees into two simpler vectors, 8.66 to the left and 5.0 up. All right? So what we're going to do over the next few minutes is find the x and y components of some of these vectors. And then after that, we're going to combine what we did yesterday with what we're doing right now, finding these components, and do problems like we had on our quiz, except that involve funny angles. You guys had, I believe it was 6 questions for homework. No, it might have been 7. Actually, no, I think it was 8. It was 6 to 13. How many questions is that? I think it's 8 questions, actually. 8 questions, yeah. 6 to 13 on page, on your worksheet, your two-dimensional vector worksheet. All right, let's go through these. Hey, what's the x? We'll go through all of them here because they'll go pretty quickly for us. What's the x component of 25 meters? We're talking about question number 6 now. What's the x component of 25 meters? 25. What's the y component? 0. What's the x component of 8 meters? 0. What's the y component? -8. Good. What's the x component of 100? -100. And the y component is 0, right? No funny angles here that we have to deal with, right? But we still got to be able to deal with the x and y components of those. Now it gets a little bit tougher because now we got our funny angles. And we don't like funny angles, so we got to get rid of them. Now, if we're doing a vector diagram where we have 3 or 4 or 5 vectors, then usually what we'll do is take our funny angle off to the side and redraw it, just so it doesn't get cluttered. But since I already have it redrawn here, all I'm going to do is draw my little triangle around it. Here's my x, here's my y. I don't want to do it over here. Right? I don't want to do it over here because the angle's not inside the triangle. Draw your triangle around the angle. All right, we got to find x here. Remember, SOHCAHTOA. SOHCAHTOA. Sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and then of course tan is opposite over adjacent. We're not going to use tan for any of these. Want to find the value of x here? What side of the triangle is x? Opposite or adjacent? Adjacent. We have the hypotenuse, so what are we going to use? Cosine. We'll say cosine 30 degrees is equal to adjacent over hypotenuse. X is equal to 8.66. The y component, we're going to say it's the opposite side, so sine 30 degrees is equal to opposite over hypotenuse. So y ends up equaling 5.0 meters. Good. How many people got that? Good. Excellent. The next one, we're going to draw our triangle like this, up and over. This would be x, this would be y. Which side of the triangle this time is x? Is it opposite or adjacent? It's opposite this time. So if we're looking for the opposite side, given the hypotenuse, which trig function will we use for the opposite side? Sine. Let's say sine 60 degrees is equal to x over 50. X ends up being equal to 43.3 meters. And we're going to say cosine 60 degrees is equal to the adjacent side over the hypotenuse. And that ends up being equal to 25 meters. Good. Honestly, now we can do any of these. The reason that I say now we can do any of these after we've done the first 2 is because that encompasses every different thing that we're going to see. We have our angle labeled from the x-axis or from the east, and we have our angle labeled from the y-axis or from the north. We've got north of east, and we've got east of north. Okay, when you're dealing with something like this, it's going to be cos for x, sine for y. When you're dealing with something like this, it's going to be sine for x and cosine for y. We won't go through the rest of them in their entirety. We'll kind of just set them up and identify which trig function you use for each one. So for this one, hey, we're going to draw our triangle like this. Which trig function would we use for x here? Cosine because it's the adjacent side. Cosine 60 is equal to x over 100. I think that's going to work out to be 50, isn't it? Okay. Sine 60 is equal to the y component over 100. Now for the next one, triangle is going to look like this. Okay, which trig function we're going to use for the x component this time? Cosine or sine? It's cosine because the x component is the adjacent side. How do we know it's the adjacent side? It's touching the angle. But suppose that 40 meters touching the angle. But that's the hypotenuse because it's the longest side. The longest side is not the adjacent. Like, let's get that out of the way right away. The longest side is the hypotenuse. The other two sides are opposite and adjacent. The one that's touching is the adjacent. The one that's not touching is the opposite. So cos for x, sine for y for this one. How about this one? Which trig function do we use for x this time, cosine or sine? Cosine because x is the adjacent side. We're going to use sine for y because y is the opposite side. Good? You guys feel comfortable with that? All right. So what happens now if we put that together? If we put that together with the quiz that we did and the questions that we did over the last couple of days. In other words, what happens if we have a question like this? Maybe we're walking 10 meters to the east. Maybe we're walking 5 meters to the south. And then maybe we're walking after that 20 meters at 30 degrees. 30 degrees what of what? This would be south of east. That angle is measured from the east axis. So it's south from the east. We're going below the east, or south from the east, or south of east. How would we analyze this one? Well, the first thing that I want you to do is recognize that there's a funny angle in this, and I want you to say 5 words in your head or out loud. Just if it's a quiz day or a test day, don't say them out loud. I don't like funny angles. So let's take this one off to the side and do what we did for those 8 questions that we had for homework here. We've got 30 degrees labeled here. This would be x, this would be y, and this would be a value of 20 meters. Which trig function are we going to use in order to find the x component? Which side of the triangle is x? Is it opposite or adjacent? It's adjacent. It's touching the angle. So it's adjacent. Let's say cosine 30 degrees is equal to adjacent over hypotenuse. X ends up being equal to 20 times cosine 30. 20 cosine 30 should work out to be 17 point, I think it's 32. And the y component is going to be found by the sine function because it's the opposite side. Sine 30 degrees is equal to y over 20. This one's easier. Y is equal to 10 meters. You know what I like to do? I like to block that off. I like to take it over to the side and just draw a little square or rectangle or some kind of shape around it, just to remind me that it's kind of extra, right? It's not what we did on the quiz this morning. It's outside of that. It's an aside. Yeah. I'm sorry. Oh, okay. No, it's not a problem, but I'm going to address that to everybody here, though, because it's a good question. What if we didn't do the y component this way? What if we said a squared plus b squared is equal to c squared? Now we have c, right, c, and we have the value of a. Could we find b using the Pythagorean theorem? Yes. Okay. The danger of that is if you made a mistake with x component or you rounded the x component, then you're going to have an issue with the y component. So I would prefer you to use sine for y in that case, but it's certainly not wrong to use the Pythagorean theorem. All right, now listen carefully. Here's what I would like to do. I would like to take this 20 meters over here at 30 degrees and get rid of it. Remember I said I don't like funny angles? Well, then get rid of it. What have we just done? We've just got rid of it. We know that we have a new vector that can replace that 20 meters, 17.32, and another one that's goes downward at 10 meters. So I've just replaced my 20 meters at 30 degrees south of east with a 17.32 to the east and a 10 to the south. It's not drawn to a very good scale. Let me just fix that up a little bit. Does that make sense? This is no different than what we just saw, except that now we don't have the funny angle there. And guess what? We know how to analyze this. We just had a quiz on this, and we did a really good job analyzing something like this. Draw your resultant vector from start to finish. Now, we don't have a right angle triangle, but we can get one. We can get one by doing our x components and our y components. The x component of the first one is 10. The y component is 0. We have 0 and -5. And then what do we have for the third one? 17.32. And the y component is, you could say 0 and then go to a fourth one. Or we could just say the y component is -10. Because really that green one is one vector, right? Whatever you'd prefer to do there. Does that make sense? We're turning the 20 meters at 30 degrees, an angle that we don't like, into two vectors that we don't have any problem with at all. 10 plus 17.32 is 27.32. 0 plus -5 plus -10 is -15. We're going to combine those now. 27.32 and -15. Not drawn this to a perfect scale, but you can still see that the resultant vector should be the same resultant vector as we had drawn in our original diagram. Find R, right? Usually I don't even label the negative in there. It's okay to label the negative. Why do I not need the negative there anymore? Yeah, Alex? I'm sorry? Well, yeah, but usually we say like, well, it's a vector, right? We should include direction. Julian? Yeah, we really have to show direction because it's a vector, but the negative is what gives us the direction when we're adding numbers together. But when we have a picture, the arrow can show the direction for us, right? So we've already got it taken care of there. When you're putting into the Pythagorean theorem, do not include the negative. Okay, just make them positive. So that R is the square root of 27.32 squared plus 15 squared, and then theta would be inverse tan of opposite over adjacent. I'm going to say you guys, let's say Jillian over this way, you guys are going to find R. Logan over this way, you guys are going to find theta. So this side of the room, theta, this side of the room, going to find R. Zach, number 1, 31 meters. Okay, thank you. And let's go, Nick, you got this one? 29 degrees. We should have actually labeled that, right? Theta right here is 29 degrees. And what would we say there? 29 degrees what of what? Where are we measuring that from? Are we measuring it from north, south, east, or west? Yep. We're measuring it from the east, and we're going south from the east, so we're going to say it's 29 degrees south of east. Good? What's different about this question than the quiz question that you guys did a really good job on? This stuff over here, that's what's different about it, right? We're turning that 20 meters at 30 degrees into a 17.32 in a 10 meters. Once you've got that done, it's the same question. If you got 7 out of 7 on the quiz or 6 out of 7 on the quiz, then you're in good shape for doing what we're doing here today. You just need to do that one extra step, take it off to the side, okay, break it into X and Y, and then going back and treating it like the problem we had on a quiz. Right? You guys want to do another example, or you're okay? Sorry? Maybe. Tell you what, let's compromise. Let me give you one on the board. Let me give you a couple minutes to work on it yourself. Okay, the one that I give you on the board. And then we'll go over it. And then once we feel like we're okay with that, then I'll set you free on a couple other questions to work on. All right. So here's another example. So we've got, what do we got? 5 vectors this time. Only one of them is a funny angle. So that's good. All we got to do for this one is get rid of one funny angle. By the way, if we had 2 funny angles, we just do that off to the side thing twice. That's all right. And replace both of them with an X component and a Y component. Let's see what we can do with this one over the next couple of minutes. Then we'll take a look at it and set you free on some work yourselves. We got one funny angle here, so we take it off to the side. We got 5 meters, and it's got an X component and it's got a Y component. Remember that X component and Y component have nothing to do with any of the other vectors here. It goes back on the 20 meters, but it has nothing to do with the 20 meters. This side is not 20 meters. It's not related to the 20 whatsoever. The only thing that's at a funny angle here is the 5 meters, so that's the only one that we're including off to the side here. All right, so now we got to find the X component. Because the X component is the adjacent side of the triangle, we're going to say cosine 30 degrees is equal to adjacent over the hypotenuse. X ends up being equal to 4.33. And the Y component, since it's the opposite side of the triangle, we're going to use sine for that. Sine 30 degrees is equal to opposite over hypotenuse. Y ends up being equal to 2.5 meters. Okay, there we go. Box it off, just so it doesn't get cluttered with the rest of it. And then let's replace that 5 meters at 30 degrees, because I don't like it, so I might as well get rid of it as soon as I can. Going to replace it with 2.5 down and 4.33 back this way. Now, does it matter whether I draw the X or the Y first? No. Why did I draw the Y first here, do you think? Yeah, just so it wouldn't look so odd and cluttered, right? If I had drawn the 4.33, it would have been on top of the 20, and that would have just got messy. So I do the Y component first. Doesn't really matter. Just easier to see it, I think, if we draw it like that. All right, I'm going to leave you with this for a couple more minutes, see if you can finish this off. But at least now we've got a problem like we had on our quiz, which you guys know how to do, right? So keep working on that, and then we'll finish this off in just a minute. All right, let's finish this one off now. X components, Y components. Tell me what the X component of that first vector is at 20 meters. 0. What's the Y component, Bruce? Negative 20. Good. What's the X component of the second vector there, Emily? This one here? Sorry, what is it? 10. Good. And what's the Y component? 0. Good. What's the X component of the third one there, Logan? 0. And the Y component is 10. Good. Holly, what's the X component of the fourth one here? This 20 meters. 20. And what's the Y component? 0. And what's the X component of this fifth one here? Taylor, what's the X component of the green one here? No, the X component. Good. Negative 4.33. And the Y component is negative 2.5. Good. So let's combine these now. 10 plus 20 plus negative 4.33 gives me 25.67. And negative 20 plus 10 plus negative 2.5 gives me, I think, negative 12.5. We redraw that. 25.67, 12.5. We label theta position 1, 2, or 3. 1, 2, 3. It's position 3. Yeah, because it's always drawn at the start here. We're going to find the value of R. What is the value of R? 28.6, so we're going to say to 2 digits, 29 meters. And theta would be the inverse tan of opposite over adjacent, 26 degrees. What would we say? 26 degrees what of what? We'd say south of east, right? We're measuring it from the east, but we're going south from the east. So we'd say it's south, from east or south of east. Good? Okay, here's what I'd like you to do right now. The last 3 questions on your 2-dimensional vector worksheet. 14, 15, and 16, please.